So hello friends, I am Neeraj. In this session we will be talking about arrays and slices. So before moving into onto arrays and slices, so let us first understand a little bit how variables are stored into our actual memory locations. So basically let me first draw it, so that would be a better way to understand. And our memory basically is divided into something like similar like this. So each memory block is having a specific address. So this is our RAM, and this RAM is divided into something similar. So when we for example say when we call it anything, for example say if we try here if we declare a variable x equals, let's say 10. So what is happening here is that the compiler is basically assigning, we are telling that put the value 10 into the variable x, and this variable x is basically going to be stored somewhere in our memory. So for example say this time this x is assigned to at this memory address. So this x would be here. It may be printed, however this is just for the visualization purpose, so don't think of it like actually this is happening just like that. So here x, and the value would be, let's say 10, and this memory address may be having something similar like it is basically hexadecimal numbers, so one something similar, maybe whatever. So okay, so try to think of it just as a conceptual demonstration purpose. So this is how our actual memory works. So now coming back to, so cause we have to study about our let's say we are trying to understand what our arrays are. So basically let me also clear it out here also, so that would be better, and this one also, and this one also. Okay, fine. So arrays are basically, so with the variables, so there is one problem. So we can specify one single variable can store only one single values at any given point of time. However, we can reinitialize it. We can assign different value to the variable. So that is okay. But we cannot store multiple values into one single variable. So that is why array are handy, and with arrays we can store multiple values of single type into one single variable. So let us see that how we can declare and we can use the arrays. So they are very simple. So x equals, so we have to specify the square brackets, and we have to specify the length of the array which we need. So let's say we give it and by the way this length cannot be a negative number, so it should be a positive number. And after we have to specify the type of the values that this array is going to store. So for example say we specified int, and we in the curly braces, so we can initialize it also simultaneously. But let us first see that what will happen if we simply go that way. So printf, and here we will say values in x %v, and we'll also say new line, and here we will say x, provide x as the argument. Now if we try to run it, I'll open the terminal and I'll say go run min.go. So what will happen is that it is printing it is basically since our array type was underlying data type, that is this array is going to store is a int. So that is why all the values are initialized to 0. So this is one property of a array, that we can store only one array can have only same data types. So we cannot mix and match, like we cannot have an array cannot store multiple data types, like we can there would be an error. For example say if we go that way 2.2, So basically that would be an array, that would be an error. So all the data has to be of the same types. So since we have initialized, we have told the compiler that we want an array of a int type. So that is a limitation of array. So when we run it, so here it would be 1, 2, 3, 4 and 5. And the indexing this array element, we can access it by their indexes also. So let's say we can say we want the value of variable of array x at the 0th index. So we can access the individual element inside this array. So 1, 2, 3, 4, 5. So we can access independent elements, and all these are called elements of the array. So we can access those elements, independent elements, using their indexes. So indexes starts from the 0 and that goes up to the length of the array -1. So now if we try to conceptualize, to visualize how this is going to be stored in our actual memory, so we will understand that thing also. So that is actually required to understand how array works. So for example, say with this statement at line number 7, what we are telling is that we are trying to create an array, and that would going to be stored into the variable x. So when this line got executed, so x will be assigned a certain address into the memory. So for example, say x comes here, okay, and array is having one specific property with them, that all the elements of that array that would be stored into contiguous memory locations. So that is why what compiler will do is, when this line got executed, or when the program got compiled, so actually, so since it knows in advance that okay, so this array is going to have 5, the length would be 5, so it will reserve the contiguous 5 memory addresses into RAM, and that would be and the first location would be assigned to the variable x. So how it will be presented here? So for example, it is 1, 2, 3, 4, 5. So this is the 0th index, this is 1, this is 2, this is 3, this is 4, and this is 5. Okay, and at the 0th index we have 1, at the first index we have 2, at the second index we have 3, at the third index we have 4, and the fourth index we have value 5. So basically these are reserved for this whole array, that is the name of the array would be variable x. So when the program gets compiled, so also this contiguous memory locations would be reserved for this array. And maybe at the fifth, at this very location, maybe we can have a variable, let's say y, and it can be maybe a string, maybe anything. I mean, maybe a string, or maybe like or some name. Like let's say my name is something similar. So it can be anything. So this is how this array works. So let me clear this out, and so I believe like now this should be clear how array works in actual memory. So let me also clear this whole thing, so that we could have it be lots of spaces. So we have seen how we can access the individual element in our array, and every array is having certain properties. So we can have the array is having a length, and array is having a capacity also. So we can get the length of the array, and we can also get the capacity of the array. So we can pass in for getting the length. So we will use the len method, and we can specify provide the x as the argument to len method, and there is another method cap, and we will pass the the variable our x into cap. And now if we try to run our same program, so we will see the values are 1 2 3 4 5, the length is 5 and capacity is also 5. So basically for an array, so length and capacity, they are equal, every time they are equal, cause for array we cannot grow and we cannot add more elements beyond the length of the array that was specified. So if we try to add one more element, and let's say 5, and if we try to add 6, so basically this program will not compile. And if we try to run this, so basically this says that index 5 is out of bounds. So we have the length of only 5, so this array can store only up to the 5 element, and all we are trying to do is we are trying to add the 6th element to this array, and that is beyond the scope, beyond the limit of this array. So that is why this is a compile time error and our program won't be compiled. So this problem can be overcome by using slices. So slices are like arrays, but they can be but we can expand it, so they are much more flexible. So in order to specify in a slice, so that is also pretty much obvious, just like an array. So we have to specify this square brackets, but for array we have to specify the length, and for slices we don't need to specify the length, and all we have to do is something similar. And now if we try to, I will just copy this whole thing and will paste it here, and I will also replace the value x to y like this and like this. And now if we try to run this program, so here we are getting the empty slice, so because we didn't add anything into it, and the capacity is also 0, the length is also 0, and capacity is also 0, because basically this is an empty slice. So we can specify the elements into our slices while we are declaring it. And now if we try to add this to run this program, so here we are getting our values of y is 1 and 2, and length is 2, and capacity is also 2. But we can add more elements into our slice, unlike arrays. So we can use the append method, and append takes in the first thing it takes is the name of the slice, and second thing is it takes as the value what needs to be added. So let's say I'm going to add a value 3, and what it returns is it returns another slice. So ideally it's better to collect the return slice into the same slice where we are appending. So now if we try to run this program, so here the value is 1 2 3, because initially it was 1 and 2, and we added number 3, and the total length is 3, and capacity is 3, cause reason being that we added one more element to our slice. So that is why the capacity has also got increased, cause we have the 3 elements. Previously we had 2 elements. Actually we had 2 elements. So our Go compiler is smart enough that it basically tries to accommodate that many of value that can be added in future. So previously we had 1 and 2, we had 2 elements, and it tries to make the capacity of double of the previous elements. So right now the capacity has grown to 4, so that means that we can add up to the 4 element in our slice. But what if if the capacity if we tries to add some more stuffs. So now if we try to run this, so basically it keeps on adding whenever we add a new element to our slice. So basically it tries to accommodate the in future whatever element that can be added. so it tries to accommodate that step. So that is why, that is how we can shrink, we can grow our slices, and unlike arrays. So these are the main differences between an array and slices. And most of the time, very honestly, most of the time we use slices in day-to-day life because they are much more flexible. So by the way, so this was one way of declaring the slice, and there is another way also. And another way is by using the make method. So by using, so for example, say we try to create a slice named Z, and this time I'll go with make method. So make method, first it takes that what needs to be, what we need to create. So we need to create a slice of int. So we have to specify this square brackets and the type. And this time we have to specify the size, the initial size. So let's say we need to create an initial size of 5. So there is one more thing which we can pass on. So but first let us see what will happen if we go only this way. And I will replace this y2 with z, and this one also, and this one. Now if we try to run our program again, so the values of z in the z are all zeros because the values are not initialized. However, the type is int, so that is why we are getting all zeros. Length is also 5 and capacity is also 5. But while we are creating this slice, so we can also specify the initial capacity that this slice needs to hold. So let's say we pass in the 10, and what will happen is when our program gets compiled, so actually in memory, so basically 10 contiguous memory locations would be stored, would be reserved for this slice named Z. Okay, so and also like we can access the individual elements of this slice like this. So Z 0, and we can initialize to 1, and 1, let's say 2. So we can access the individual elements just like array and regular slices. So I think everything should be clear, and still there is any confusion or any query, so please do let me know in the comment section, and I'll try to explain to clear out as soon as possible. So till then, take care, and I'll see you in next session.